So in the last video, we used specific rectangles in order to approximate the area of a region. Now, one thing to note is that if we increase the number of rectangles, so what we did in example 4, you could obtain a more accurate approximation of the area of the region. So for instance, if we instead use 25 rectangles, each of a width of 2 over 25, you can approximate the area to be 9.17 square units. And so notice we did 100, 1,000, 5,000, we would get closer to the area under that curve. So that's what we're going to do in the next example. We're going to still find the area of a region here, but we're going to find the exact area of a plane region. So based on the procedure illustrated in the previous video, the exact area of a plane region R can be found by using the limit process to increase the number n of approximating rectangles without bound. So this is an important formula that you want to use. And then so like the first problem, like number 21 here in the textbook, you want to go ahead and use this formula to help you out, just as a small little hint. So this formula is important. Make sure you write this down. So let f be continuous and non-negative on the interval a to b. The area A of the region bounded by the graph of f, the x-axis, and the vertical lines x equals a and x equals b. So notice the values here. And so we'll use that in our next example. Find the area of a region. Find the area of the region bounded by the graph of f of x equals x squared and the x-axis between x equals 0 and x equals 1. So what I first want to do is just graph this out just to see what we're looking at. And so I'm going to stretch this out a little bit, or a lot. And so this is going to be 1, and this is going to be 0, and this is also 1. Sorry, this is 1 on the y-axis. So here's my y-axis, here's my x-axis. And then so we know that a parabola is going to make this curve. So we're only trying to find the area under the curve between 0 and 1. And so that's going to be everything here. So just kind of shade that in real quick. And so number 1, so one thing that we know is that x equals 0, that is going to be A, and then x equals 1, that'll be B. So using this formula, so remember that the first value, that is going to be the height, right? The height, and this is going to be the width. So to find the width, let's do that first. It's just b minus a over n. So this is going to be 1 minus 0 over n. So the width is just 1 over n. Now the height is going to be a. So a is 0. So 0 plus. And notice b minus a times I over n. That's the same as the width here. So this is going to be 1i over n. Oh, and there's an f here, sorry. So it's f of 1i over n. And then what you do with this is what we did before, is you plug it in to this function that they give you to figure out what is each of the heights. So this is going to be I over n squared, or I squared over n squared. And so that is our height. So now let's write our area. Okay, so area equals as I equals 1 to n, and then we're going to put our I squared over n squared, our height, times the width, 1 over n. So now let's simplify this a little bit more. So we're going to multiply. So this is going to be I squared over n cubed. And let's split this up more. We can factor out the n cubed. So this will be 1 over n cubed times the sum of 1 to n of I squared. Then we're going to substitute using the summation formula of this here. So this is going to be 1 over n cubed times n plus 1 times 2n plus 1 all over 6. And then we're going to multiply. So this really is n squared plus n, and so the numerator becomes 2n cubed plus 3n squared plus n all over, and we're going to multiply 6 times n cubed, which is 6n cubed. So now we're going to use our limit at infinity. So the limit of 2n cubed plus 3n squared plus n over 6n cubed as n approaches infinity is going to be 2 over 6, or 1/3. So the area under the curve is 1/3 square units. That is the area. So try this example below. Find the area of the region bounded by the graph of f of x equals 3 times x and the x-axis between x is 0 and x is 1. So I'll be trying it out using the formula. So it's nice with the linear equation that they gave us here because that should make sense of why that is 3/2 square units. But it's the practice of finding the area of a region because the next ones are going to be parabolas. So they're a little more